Okay, today's notes are on absolute value functions and graphs, section 2.7, and our content objective is to graph absolute value functions, and our language objective is to define terms associated with absolute value graphs and functions, including axis of symmetry and vertex. So we're going to start by drawing an absolute value parent function. So our absolute value parent function, make a note that this is what we are working with. As we mentioned in our last notes, is y equals the absolute value of x, or f of x is equal to the absolute value of x, saying the same thing. And since this is our function, if we were to test out a set of values, so if we write a table of x and y coordinates and go from, say, -3 to 3, if I take the absolute value of these of each x value, so I plug in -3, then I'd get 3. If I plug in -2, I get 2. -1, I get 1. 0, I get 0. 1, I still get 1, and then 2, and then 3. So if you notice, all the values are going to be positive, and they are mirrored from one side to the next. So you start at -3 until 0, and then it's mirrored back up to the positives. So if we graph this, as we mentioned, or we saw briefly in the last video, we have our x and y axes. It's going to end up being a V. So our absolute value function ends up being a V, just like that, because we're never going to have negative values in this situation. But as we'll see, we can transform it to get absolute values with negatives, but we'll get there in a second. Other key features of an absolute value graph, as we mentioned in our language objective, are the axis of symmetry and the vertex. So the axis of symmetry, to start, is a vertical line the graph is symmetric about. And since symmetry and symmetric is kind of a circular definition, I think another way of explaining it is mirrored. Sorry. So it's a graph that is mirrored about, or it's the line that the graph is mirrored about. So it's kind of the line that cuts your V in half. So it'd be, in this case, the y-axis. I'll draw another demo in a second. But the other key term we need to know for absolute value functions is the vertex. And this is the single maximum or single minimum point. So if we quickly sketch another absolute value graph that's not just like our parent function, so I have my y and x axes. If I just draw another unspecified absolute value function, our axis of symmetry is this dotted line that I'm drawing here. So again, it's a vertical line. It would be written as x equals some number. So I'll leave that blank, but it'd be x equals something, and that would be the equation of the axis of symmetry. And the vertex is the single maximum or minimum. In this case, it's a minimum point. And this would be the vertex, and it'd be written as a coordinate x comma y. But our vertex is that point, and our axis of symmetry is that dotted line. All right, I'm going to turn the page so we can talk about how we will use our parent function in these terms to make all the absolute value functions in the absolute value function family. I'm going to flip the page. So this is great because it's building again on what we talked about in our last lesson. So we apply transformations to our parent function, or to the, I'm going to abbreviate absolute value as AV, and I'll do that a few times this lesson just as a warning. Parent function to create other functions in the absolute value family. So this is why we learned about transformations last class, because now we're going to apply these transformations to our absolute value parent function to get all the other absolute value functions we'll talk about. So some things I want to highlight before we jump into doing those examples are some key features or key information from the parent function and this is for absolute value functions. So some key parent function information about absolute value functions include the vertex. So the vertex of our parent function, if you look at our last graph, is the coordinate 0, 0, so it's our origin. So the vertex of the parent function, the simplest place is 0, 0. Our axis of symmetry, which I'm abbreviating AOS, I can write it out here this time, is going to be x equals 0. So again, it's a vertical line, so it's going to be x equals a number, and the place where it cuts in half is going to be the vertex. So it's always going to be the x coordinate of the vertex, just as a note in your head, or jot this down somewhere. The vertex and axis of symmetry are connected because the axis of symmetry is always the x value of the vertex, so x equals 0 in this case. And our slopes for either side of the v are m equals -1 and m equals 1. So if we look at a quick mini sketch of the graph, it would be -1 on this side and +1 on this side. And the last thing I want to note is that it opens upward. So our v opens upward. So these are some key things that we should note about our parent function, because when we apply transformations, these are the kinds of things that will change or move based on our transformation. So it's helpful to know where we're starting so that when we build upon it, we know what we're changing. So now let's actually do an example of how we can change this function. I want us to sketch the function y equals absolute value of x plus 2 plus 3. So we know our parent function is y equals absolute value of x. Now we're applying some transformations and we're going to resketch it. So we're going to have the same steps for most of our examples today. So the first thing I want to do is determine my new vertex. This is a helpful place to start. Since my vertex is at 0, 0 to start, it's going to be easy to figure out where my new vertex is because I'm just going to look at the translations, so the things that are being added or subtracted to my function, to figure out where my new vertex is. So I'm also going to quickly sketch an x and y axis so I know what's going on. 1, 2, 3, 4. Okay, so my new vertex, originally it was at 0, 0. Now I'm going to apply my transformation, so I know this is going to be a horizontal translation because it's inside the function, it's inside the absolute value, so it's horizontal. And since it's being added, I'm actually going to go in the negative direction because I do the opposite for horizontal translations. So I started at 0, 0. Now I'm going to go 2 to the left, and then this is my vertical translation. It's adding 3, so I'm going up 3. So I go 2 to the left and then up 1, 2, 3. And my new vertex is going to be at the coordinate -2, 3. So I can find my vertex by just looking at the translations every time, which is really helpful. So I'll make a note of that here. So I'm just going to look at my translations, and that will tell me where my new vertex is. The second thing I want to do is determine the new slopes. And to do this, I'm going to look at the vertical stretches or compressions. And in this case, there isn't one, so I'm going to keep the same slope. So if there's no vertical stretch or compression, I'm going to follow the same slopes I did previously. So on this side of my V, it's going to go down, and this side it's going to go up by 1. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. And I could continue that on, but I'm just going to draw a straight line through. And same here, I'm going to go up 1, this way 1, up 1, this way 1. And again, I could continue that on, but for the sake of time, there's my new absolute value function. So the last thing I did, or last couple things I did, was plot my new points. So I followed my slope and plotted the new points. And then I sketched my graph. So those are the 4 steps we're going to follow throughout this process to make sure we're sketching our new function correctly. I'm going to have you guys do a quick check, or a couple quick checks. The first one I want you to do is sketch y equals 1/2 absolute value of x. So try that on your own. Pause the video if you want to practice it. I'm going to try it now. So pause it if you haven't finished this. So I'm going to draw my y and my x-axis, 1, 2, 3, 4, 5, 6. Okay, so for this one, there are no translations. So when I'm determining my new vertex, I don't need to move it at all because there are no translations. So it's staying at 0, 0. So I can plot my vertex there. For my new slopes, this is actually coming into play this time. So I see that my new slope is going to follow my vertical translation. So instead of being -1 and 1, it's going to be -1/2 and 1/2. So I'm going to go up 1 over 2 to plot my new point, up 1 over 2, up 1 over 2. And so this side is going to go like that. So you can see it's compressing, it's getting flatter, and this side is going to be similar, up 1 over 2. And if I draw that one, it'll go that way. So I just plotted my new points based on the slope that I'm following from my vertical stretch or compression. In this case, it's a compression. And then I'm sketching my graph. We're going to try another one together. So I'm going to flip the page. We're going to do one more quick check together. I want us to sketch f of x equals negative absolute value of x minus 1 plus 2. So try that on your own, pause it, give it a try. I'm going to go over it now. If we haven't finished it, pause it. So I'm going to sketch this. Here I have my y-axis, my x-axis. Okay, so first thing I'm going to do is determine my new vertex. So my new vertex, I'm subtracting 1 in my horizontal translation, which means I'm actually going +1 in the x direction, and then I'm adding 2 in my y direction. So my new vertex is going to be the coordinate 1, 2. So I plot my vertex 1, 2. And now my slopes were originally -1 and 1, but since I have a negative sign in front, there's going to be a vertical reflection. So I'm going to flip or change all my y values and switch my slopes so now they're going opposite. So on this side of my v, it's going to be positive. I'm going to go down 1 over 1. And on this side, it's going to be negative. So I'm just reflecting my graph because I have a vertical reflection. So now it's opening downward. And I have my new function. So make sure you write down any questions, comments, concerns you have on this process. We're going to do one more example together of going the other way. So if we're given our graph, so I want us to write the equation for the following graph. And I'm going to do my best to sketch it neatly for you all. X-axis, y-axis will go 1, 2, 3. Okay, so I'm going to plot this at the point 2 or -2, 2. So I'll drop this here. And then I'm going to plot this point and this point. All right, so this is our graph. I want you to try to write the equation for this graph on your own. Or sorry, no, I'm doing the examples. Sorry. So what I want us to first do is determine the vertex. And then I'm going to write these as translations. So I'm just doing the reverse order of what we did previously. So my new vertex is -2, 2. So if I'm writing my equation, I know y is equal to the absolute value of x. Since I'm going in the negative x direction, I know it's going to be the opposite. I'm going to add it. So I have x plus 2, and then I went up 2 in the y direction. So outside the absolute value, I'm going to add 2 also. So it's going to be plus 2 in the absolute value, plus 2 outside the absolute value. So I did my horizontal translation and my vertical, and I plugged them into my equation. My next step, step 2, is going to be determine my new slope. And then I'm going to write these as vertical stretches or compressions. So if I look here, my original slope is down 1 over 1, but this seems to go down 2 over 2, down 2 over 2. And it's opening downwards, so I know it's going down. I have a vertical reflection, so I have negative, and then it's going 2 instead of 1, so it's going to be negative 2 as my vertical stretch, x plus 2 plus 2. So that is my new equation. I want to make a note here. When you're determining your new slopes, you can also write your reflection if applicable. So you're going to write your reflection in that section as well, and then you'll have your new equation. So our new equation is right here. Make sure you jot down any questions, comments, or concerns you have on this, and we'll go over some more together in class.